I'd like to talk a little bit about some examples with recording errors. Specifically in physics, when we talk about errors, we're not necessarily talking about making a mistake, but we're talking about measurement errors. So when you do a measurement in any lab in physics, you don't just get the result, but you also have to report an error. And so this is kind of two good ways right here. These are two good examples of how you might do that. So if somebody measured, maybe with a ruler or something like that, 25.47 centimeters for some length, but you have to report an error. And you can also say you have to report an estimated error. Now, what does that error mean? It's an estimate of the amount of uncertainty. Some physicists will actually call them uncertainties. Or you could say it tells you like how precise the measurement was. The smaller this number is, the more precise it is. The bigger the number it is, the less precise it is. Conversely, you could say the smaller the number is, the lower the uncertainty. The bigger the number is, the larger the uncertainty. It's meant to kind of be a description of how much you think, like, hey, if somebody else came in and did the same measurement over again, are they going to get exactly like 25.47 every single time? Probably not, because most likely, especially this last digit here, they probably had to eyeball that a little bit with whatever instrument was being used. And so somebody else might have looked at that and said, oh, I'm saying it's 25.45. Somebody else might have said, oh, maybe it's even higher than that. But generally speaking, we expect some number, maybe I'd say roughly, conventionally, at least 2/3, maybe a little bit more, somewhere between 2/3 and 3/4. There's a thing called the empirical rule that says that of the measurements, if you did it repeatedly, should fall within the range that this plus or minus error estimate is telling us. So again, these are good examples. There's two ways to record them. The important thing is there's units on both the measurement and the error. But this is also okay, the second version right here, where you have the unit and you've got a set of parentheses. So it's kind of like I'm thinking about this unit distributing maybe over both of them. I like to use this one, especially if I'm writing in my notebook, and in my haste, I write the measurement and the error and then realize I forgot to leave enough space for the unit right here. Well, then I put some parentheses and put the unit there, and that is okay notation. I've got a not good example here, but maybe an even simpler example than this one of not good would be to accidentally leave out the units on the error. Like, let's say I didn't have the centimeters there. That would also not be good. What's not good about this one, though, is there is an issue in terms of where do I round things off? And many of us are used to maybe like significant figure rules for problems. Many science classes use those, but this is actually a different system. So the significant figure rules, usually like if somebody reports like a 25.47 and doesn't give you an estimated error, you just assume that there's some amount of uncertainty in the last digit. But in this case, we're being very explicit. No, here's what we think the uncertainty is. So again, this is basically a kind of better, a more precisely communicated system for dealing with uncertainty. It does the same job, but it has different rules. So what's wrong here? Like, there's two issues, I think. For one, I've got an error here that has, how many significant figures does this have, right? Like 1, 2, 3, 4, 5. And it turns out that's ridiculous for an error. An error is supposed to be an estimate of how uncertain you are about this number. This is the number I care about. This is the number that anybody reading a paper I publish with this result would care about. This is the number I'm going to care about when I look at labs in this class, right? So I don't need that many digits on that. In that sense, if I just write here plus or minus 0.05 centimeters for that error or uncertainty, that is good enough. But if I really did this measurement, and if that was my error, it should be a little weird maybe that I got exactly 35. But if I really think that that's what I got, then I had better write 35.00 centimeters. In other words, the place of rounding, in this case the hundredths place, should match on both of these numbers. In addition, I should not have too many digits on the error. So there's kind of another, I put another little example up here with the question where to round. So I've got two possibilities. Let's say I had an error that for some reason, I actually have no idea why the error would be that number. That one's kind of one that I made up, and it turns out as we go further in this course, I'm going to share with you some simple rules of thumb that people use for certain instruments for measurement errors. We're also going to explore, in some cases, some methodologies for if you don't have a rule of thumb, how do you establish what the measurement error is for a particular type of measurement, and that's something that there's no like real one rule that covers all that. But let's say for some reason I had this as my error, and the usual default rule is that errors are reported at 1 digit of accuracy. But this one here is reported as 2, so if I follow the 1 digit of accuracy rule, I should round it off here, and then I should also round off, like that's the hundredths place, right? So the measurement should also be rounded off, therefore, to the hundredths place. However, the issue with this is like a 40%, I think, reduction, right? From here to here just by rounding. So it is okay to keep 2 digits for the error if the leading digit is small. You might ask, well, how small is small? Well, 1 is as small as it's going to be, and yet still be a significant digit and not a placeholder 0, so obviously 1 is going to be okay. I'd say 1, 2, and maybe 3 are okay. I used to work at a school where they kind of like, that was the rule and you didn't disobey that rule. My answer is like, well, it's a little bit up to you. You can either have an error that's at 1 digit of accuracy or 2, and I leave it up to you to decide where you want to draw the line between the two. But I'm going to say between these two, I actually think the top one is the better choice.